Now we're going to look at two examples of um, propagation speed. The first one is about the speed of a pulse on a cord. A uniform string, uniform, has a mass of 0.3 kilograms and length of 6 meters. So the mass of the string is 0.3 kilograms. The length is 6 meters. So I can find the mass per unit length because it's uniform. There is only a constant mass per unit length. M divided by L, it will be equal to 0.3 divided by 6, 0.05 kilograms per meter. The string passes over a pulley and supports a 2 kilogram object. Therefore, this 2 kilogram object is at equilibrium, so it has to have a weight mg and a tension T. So free body diagram gives me for this mass its weight mg and tension T. And so let me clarify that this is a different mass. It's the mass of the object, capital Mg, because I also have mass of the string. And the net force on the y-axis is 0. This is in equilibrium. It's supported. Tension must be equal to mg. So it is 2 kilograms times 9.8 meters per second square gravitational acceleration. I find 19.6 newtons. Find the speed of a pulse traveling along this string. Well, the speed of a pulse traveling on a string is square root tension divided by mass per unit length. So this will be equal to square root 19.6 divided by 0.05, and the answer is 19.8 meters per second for the propagation speed of a pulse on this cord. Another example we can look at, an 80 kilogram hiker. Okay, so we have a hiker. Mass of the hiker is 80 kilograms. Is trapped on a mountain ledge following a storm. A helicopter rescues the hiker by hovering above him and lowering a cable to him. The mass of the cable is 8 kilograms. Mass of the cable is 8 kilograms. Its length of the cable is 15 meters. So it has a mass per unit length. Mass of the cable divided by length of the cable, assuming it's a uniform cable. This should be 8 divided by 15, 0.53 kilograms per meter. A sling of mass 70 kilograms is attached to the end of the cable. So here, this is the cable, and here is the sling he attaches himself into, and here is the helicopter, and here is the hiker. All right, and the sling has a mass of 70 kilograms. Mass of the sling is 70 kilograms. Is attached to the end of the cable. The hiker attaches himself to the sling and the helicopter then accelerates upward. Terrified by hanging from the cable in mid-air, the hiker tries to signal the pilot by sending transverse pulses up the cable. So this hiker is terrified, and therefore what he does is he sends a pulse to the pilot. So this pulse is going to propagate with a certain propagation speed and go to the hiker to go to the pilot to alarm him that the hiker is terrified. A pulse takes 0.25 seconds to travel the length of the cable. So the delta t, the time it takes for the pulse to reach the pilot is 0.25 seconds. So since the cable has 15 meters length, then that means the propagation speed of the pulse should be equal to length of the cable divided by the time it takes for the pulse to reach the pilot. So this will be 15 divided by 0.25, which will be equal to 60 meters per second. And what is the acceleration of the helicopter? Assume the tension in the cable is uniform. If the tension is uniform, it is square root t divided by mu is the propagation speed. So I find that the tension must be equal to 60 squared times, it's v squared times mu, which is 0.53 kilograms per meter. So I find that the tension should be 1920 newtons. And what is the upward acceleration of this helicopter? So what I do is basically I'm going to look at where the tension is going to appear here. The tension will be applied to the sling plus the hiker. So I'm going to draw a free body diagram. Sling plus hiker. So there will be a total mass here, m total g, and there will be the tension T in the cable, and as a result the system is accelerating upward in the y direction. So the net force in y is equal to the tension minus total mass of the sling and hiker times g is total mass times the acceleration. So the tension must be equal to the total mass times g plus a. All right, so the tension was 1920 newtons. What is the total mass? For the total mass, I have mass of the hiker plus mass of the sling is the total mass that is under this tension. 80 plus 70, 150 kilograms. So this will be 150 times 9.8 meters per second. That will be equal to 150 times a. So I find that the acceleration should be 3 meters per second square. So we have to look at where the tension appears. The tension is basically applied onto the sling and the hiker, so that's why for the total mass we only take the sling and the hiker. The cable mass is irrelevant in this calculation.